Dear students, today we embark on a journey through the intricate world of printed circuit board, design, a process that lies at the heart of modern technology, enabling the gadgets and devices that have become an integral part of our lives. From smartphones to medical equipment, from automobiles to space exploration, PCBs form the essential groundwork that allows complex circuits to come to life. Let's delve into the steps involved in this captivating design process. Step 1. Component selection. Component selection in PCB involves carefully choosing electronic components that meet the circuit's required specifications, functionality, and performance. Consider factors like quality, availability, cost, and package compatibility with the PCB layout. Proper component selection ensures a reliable and efficient electronic circuit. Step 2. Schematic design. Create a schematic diagram of the electronic circuit using PCB design software. This step involves placing and connecting the components logically to represent the circuit's functionality. Step 3. Component footprint selection. Choose an appropriate component footprints for each component in the schematic. A component footprint defines the physical dimensions and layout of each component on the PCB. Step 4. PCB layout design. Transfer the components and their connections from the schematic into the PCB layout. Arrange the components on the board and route the copper traces to make electrical connections between them. Step 5. Trace routing. Carefully route the traces to ensure proper electrical connections, signal integrity, and avoid interference or crosstalk between traces. Follow best practices for trace widths, clearance, and impedance control. This is how schematic to PCB layout conversion looks. Step 6. Ground and power planes. Incorporate ground and power planes to provide stable reference voltages and minimize noise in the circuit. Ground planes help with shielding and reducing interference. Step 7. Design rule check RT. Run a design rule check to verify that the PCB layout complies with manufacturing and assembly constraints. This check ensures that there are no design errors, such as overlapping traces or incorrect clearances. Step 8. Netlist generation. Generate a netlist file that contains information about the components, connections, and their corresponding footprints. Step 9. Gerber file generation. 8 Gerber files, which are standard files used by PCB manufacturers to fabricate the PCB. Gerber files contain information about copper layers, solder mask, silkscreen, and drill holes. Step 10. Bill of materials. BOMs generation. Create a BOM that lists all the components used in the design, along with their part numbers, quantities, and reference designators. Step 11. Prototyping and testing. Before mass production, it's advisable to create a prototype of the PCB and test its functionality. This step helps identify any issues that may need correction before full production. PCB design is more than just a technical process. It's a celebration of human ingenuity and a driving force behind the technological marvels that shape our world. Let it inspire us to think big, to push boundaries, and to create a future that's brighter and more interconnected than we can imagine. Thank you for joining me on this enlightening journey through the world of PCB design. In the next session, let's see about basic electric component used in PCB.